recording, just so you know. I made your test review and your test last night. I think you guys are going to be really happy with it. I feel like it's a very, very fair test. And the review is just like the test, kind of like the quiz that we just took. You had a review, and then you had the test. And then you knew exactly what to expect. I don't think anyone said to me, well, I didn't understand how to do this on the quiz, because it was on the review, right? And the test will be the same way. And we're going to do 2 days on the review, and I don't even think we need 2 days. I really could cut one of the days, but I'm not going to. All right, so be ready for it next Wednesday, but don't be stressed about it, okay? All right, so everything we're doing today, I think every single thing is a review, everything, okay? So this is going to be helpful, right? Just more review, not really something new, and it's very, very simple math, okay? So we're talking about concavity again and points of inflection. We're bringing it back. All right, so a function is concave up on an open interval if the graph looks like a U or part of a smile, right? We know what concave up means these days. And then in this graph, I think you guys would agree that it goes to about maybe here. Now, we are going to be finding the exact place where it happens, or an estimation of it. So I'm just doing like a little estimation with my green marker there, okay? And then a function is concave down on an open interval if it looks like an upside down U or of a frown. I remember we talked about this a lot before the last quiz. Concave up holds water, concave down would dump the water out. It wouldn't hold it. And the reason I use the word dump is because down dumps it and the rate of change is decreasing. I have those 3 Ds to kind of help you remember, okay? And so we're concave down where the graph part looks like a frowny face, okay? And there's arrows on the ends of these, right? That's why it says open interval. So just don't get too worried about open interval or closed interval, but I want you to understand the language. So open interval, like we talked about yesterday, just means that there's arrows on both ends, okay? It goes on forever versus closed where it has like endpoints, or it tells us that it's only going from this x value to another x value. And a function has a point of inflection, and you know I use that POI abbreviation, where the graph changes concavity. So we kind of estimated it right about there, okay? And if anybody wants a note card, you know, to keep in your binder, they're kind of nice to have, like for a straight edge if you want it, or like it really does help me see it. And we kind of talked about this last week when we did the quiz review. I just think it's helpful. But what we're going to do now is actually find the point of inflection using a math problem. We've already done it. We've already done it. If you have 2 points, these happen to be extrema, right? This is a relative or local max and a relative or local min. And you can find the midpoint between these 2 points, and that's a very good estimation of where the point of inflection is. It might not be exact. You really won't be able to get exact until you get to calculus and you use something called second derivatives. But for now, that's one of our methods of getting a really good guesstimation of where it is. So remember, it's just the midpoint, okay? So like to find the x value of our midpoint, we just add the 2 x's together and divide by 2. Does it matter what order I add my x values in? Of course not. Addition order doesn't matter, right? I could do -2 plus 3 or 3 plus -2. And that would give me 1/2, or you could make it 0.5, right? Either one would be fine. And then our y values, we could add those 2 together. -6 plus 4 divided by 2 would be -2/2 or -1. So our POI would be at 1/2 or 0.5, doesn't matter, -1. And that makes sense. You know, I kind of estimated it around there. There's no intervals marked on our graph. It's just a sketch. So that makes about sense, right? So we'll just call that our POI of 1/2 negative 1. Oops. Sorry. Midpoint. So if you find the halfway between, or like average, you can think of it, that's why it's 2. So it'll always be 2. Okay? All right. So can you determine how many points of inflection occur in the graph shown below? I've taught you this before. I don't know if anybody remembers how to tell, just by looking at a graph, how many, not where they are, but how many POIs you have. Does anybody remember that little trick? Anybody? Yeah, number of turning points minus 1. So how many turning points do we have on this graph? 3. Yeah, we have a turning point here, here, and here, right? 2 minimums and a maximum. So that means we're going to have 2 POIs. So I have a turning point. I'll make little X's for my turning points. There, there, and there. And then think, I would have a POI. We're not going to find them. This is just asking to find out how many there are. We would have one somewhere in here, right? Maybe around there would be a POI. And then this is concave down. It switches somewhere in here to concave up. So where we change concavity, we have a point of inflection. Where we change from increasing to decreasing and vice versa, we have a turning point. So we're really dissecting these graphs, right? We're really tearing them down, picking all kinds of stuff on them. Okay, any questions before we go to the next one? We have really short notes. It's not going to take us too long. Any questions? Okay. So there are 3 typical ways to find points of inflection at this level without going into calculus. I don't want you guys to get hung up on the words here and, oh, what is this? What is that? I'm going to go through them briefly, and then I'm going to show you how on these graphs, you don't really have to know which one it is. It's going to be kind of obvious, okay? But let me just talk about it, because there are some words in here I wanted to, vocab words I want to talk about. So out of these 3, this one in the middle is the one we've been doing, the one I just did with you, okay, where you estimate a possible point of inflection between 2 consecutive extreme values. So that's like problem D, just like the one we did on the other page. Between these 2, we could find the midpoint and estimate. So consecutive means in a row, all right? Consecutive, this one, and then this is the next one. Whereas these 2 are not consecutive extrema, all right, because there's another one in between them. So these 2 are consecutive, and these 2 are consecutive. So that's all that the word consecutive means. And then we would just do the midpoint between those, the max and the min, just like we did on that other one, okay? So I'm not even going to do this one because we just did one like it. We don't need to do it again. All right. At a 0, what's another word for 0? X-intercept. What else? What? No, can't be an X-intercept and a Y-intercept. Nope. Well, except at 0, 0. What? No, that's a from here to here of the x-axis, but it's the solution. It's the x value. It's a root. You're going to hear all different types. But we're evaluating graphs, so in this case, 0 means an x-intercept, okay? And multiplicity of 3, we're going to go deeper into multiplicity later this week, tomorrow, Friday. And you might remember it from Algebra 2, so just so you understand what that means, if you had... let's say you factored something, or they said, and what's the solution? You would set each of these equal to 0, and you would get x equals 3, right? 3 times. Okay, sorry. So x minus 3, 3 factors of the same thing. If you set each of these equal to 0, you get the same thing 3 times. Instead of writing that, you might say x equals 3 with a multiplicity of 3. Maybe I should have used a different number. But it just means there's 3 of the same answer. That's what that means. How do you know it's a multiplicity? By looking at the graph. You would know that later this week, but it's not really going to matter, and I'll show you why. And then this last one we'll see also, estimate a possible point of inflection between a 0, multiplicity of 3, and the closest relative extreme value. So let's look at this. Let's look at this first one. So we have a graph with 1, 2, 3 turning points. It's kind of similar to the bottom of the page before, okay? So you're going to have a point of inflection somewhere between these two, right? This is that third rule between a 0 and a extreme value. And then also rule number 1. This is a turning point right in, a POI right in here. It goes from concave up here and then it switches to concave down, which is really nice because you don't have to do any math to find that. You can name that point. It's just 3, 0. You have a POI at 3, 0, and then you have another one in between this one and this one. And we could find it. I'm not going to spend the time on it though, okay? But we'll see that again in a second. I already talked about this one, and then this one you're going to see. This is a really common one. You can see we're concave down, and then we're concave up. So somewhere in here, right? Somewhere in this area we're going to have a POI, and then somewhere in here we're going to have a POI, right? Because we go from concave down to concave up to concave down. So there'll be one here and one here, somewhere in between. And so this is where you're finding the midpoint between this extreme value and this 0, okay? And this extreme value and this 0, okay? So I'm just going to do this one really, really quickly. Let me just name these points for you. So I need this turning point, and I need this 0, and I can find the midpoint between those two. And then I'm also going to use this 0 and this extreme value, which is to the right one up 9. Okay, so I need to identify those points, and then I can find each of the POIs. So let's find, it doesn't matter which one you do first, -4 plus -2 divided by 2. That will give me my x value. And 4 plus 0 divided by 2. Right? I just wrote it in the form of an ordered pair. So there's one of my POIs in between these two, and it makes sense. To the left 3, up 2. Okay. So there's a POI, and then we have one somewhere between these two. I'm adding my x's, any order, it's addition, as long as you put the x's first and the y's, because this is an ordered pair. Plus, and I get -1/2 and 9/2. Or I could change it to a decimal, and I get, whoops, I don't know why I didn't change that to a decimal. -0.5 and then 4.5. It doesn't really matter, okay? Just be aware, like, as I said yesterday, we have a lot of multiple choice questions in this class. You want to be able to identify, oh, why are they all in decimal form and I have an answer, or vice versa, okay? So if you get 4.5, for example, so you do 9 plus 0, and you go into your calculator and you do divided by 2. You know your calculator is going to default at this point, to a decimal. But what if all your answers are in fraction form? It's up to you. You should know, by now even, how to change a decimal to a fraction. It's just math, enter, enter. Oh, there it is, okay? All right, so there's my second point of inflection, -0.5, so to the left a little bit, and then 4.5 would be like right around there. Okay, so it's all about that midpoint for that one. All right, last thing. This is a excellent review of almost everything we've learned, and I'm telling you ahead of time, this last bit of notes is what your FRQ is going to be on the test. FRQ is your free response question, okay, not multiple choice. And there's a few things on here we're not going to do. And let's see. So this is the last thing you have to do. This is a great it's a great review of everything, and once we're done with it, your homework is really, really short. I made it short because yesterday went a little long, and if you needed extra time, you could work on yesterday's homework, like the calculator stuff, if you needed to. It's time to do that. Okay, so we have a graph here, okay, and we're going to answer a whole bunch of stuff about it, okay? Let's start with domain. What is the domain of this graph? Anybody? You can yell it out. All real numbers. So and I don't care which one you write. This is really the varsity math way of doing it, and this is more of the JV math, but either one is fine, especially in the homework, as long as you know on a test, again, I say it a lot, that this means this and this means this, okay? But for me, it's okay either way. All right? How about the range? Range is harder. So before we get to that, I'm going to tell you that your version of the notes and my version of the notes, if you notice, left off this XY chart, and she added this, I think, after we printed ours, and all that this is for is to name all these points. So if you just look, there's like -5, 0, there's that point, -4, -4, and so on. So I'm just going to fill in off of this, just so you know that's where I'm getting it. Just fill in some important points on here, and you can just go ahead and copy them onto your graph as well. So normally you would be told, and I'll tell you why. Not that this point right here is hard to identify. That's -4, 4, right? This one is -2, 0. This point is added, it's not at an exact spot. And in a minute, they're going to ask us for points of inflection. So we need to know what our extreme values are, all right? So that was in that little chart, just so you know. You could have estimated this, I guess, like 1, -8, but we'll just go with the exact numbers, okay? So just understand that's where I got it. I didn't, like, measure it out or anything. That was given to me, okay? So, and I need to know that number for my range because, remember, least to greatest start at the bottom of your graph. What's the lowest number we use? What's the lowest value we use of the range? Come on. Yeah, Nicole, I think that was you. -8.1. That's the lowest x value right there. We use from -8.1 and then up forever. So that would be included all the way to infinity. Okay, so we should be able to pull domain and range off of a graph. And by the way, the domain is that because even though it looks almost straight up and down, but we talked about this yesterday when we were trying to find zeros. Straight up and down, but it is going left and right slowly forever. Okay, it is. So that's why it's all real numbers on the x values. Okay, skip C and D. Interval where the graph increases. I mean, how many times are we going to have to do this? You can see it increases here and here. This is where you can use brackets or you can use parentheses. I'm going to switch it up and I'm going to use brackets. And we always use the x values. That's what interval means. So -4 to -2. Could I use parentheses? Yes. Okay, and then we have another one from 0.9 to infinity. But even if I choose to use brackets on this one, I will never use brackets on infinity symbols. Okay, so that's where we're increasing. And then, of course, we decrease here and here. So that's -infinity to -4, right? And, I don't know, I'm just going to use brackets. I'm going to stick with brackets. And then, but I could have used parentheses, just so you know. And then -2 to 0.9. Question on increase, decrease, you get that? Okay, relative maximum. Remember, you have 3 choices of how you can write these. It doesn't matter, as long as you're aware of all 3 types. I'm going to write them as an ordered pair, okay? And I switched it up on the key of your homework. It just doesn't matter. So we have a relative maximum right here, right? This is from yesterday's lesson. That's a relative maximum. There's no other ones. And we have 2 relative minimums. These have to be parentheses because they're ordered pairs. Don't get confused between all our notations. It's easy to do. Do we have an absolute maximum? Don't let me trick you. Do we have one? No. You can tell me no. None. No, there isn't one. Right? This is these arrows go past our only maximum. So we absolutely have absolute maximums above that. Okay? Do we have an absolute minimum? Yeah. This guy right here. He's our lowest one. Points of inflection. Told you it was coming. So we are going to find, in this case, the midpoint between these two, midpoint between these two. Okay? So let's just knock that out real quick. It's just finding. So we have one of them. It doesn't matter which one you do first. We have one of them between these two. So I'm just going to add my x values. -4 plus -2, always divide by 2. Add my y's, divide by 2. And I get -3, 2. Makes sense. 1, 2, 3. That doesn't. That's a -4. So that's a -2. Oh, I left that off, didn't I? I'm so sorry. -4. That's a negative right there. Okay. That's a -4. Sorry. To the left 4, down 4. Nobody caught it? All right. So left 3, down 2, right about there is a POI. Okay. And then the other one, we have -2 plus 0.9 divided by 2, and 0 plus -8.1 divided by 2. And we get weird decimals. They're not nice, but we sometimes have to deal with decimals in math. So we're not always going to get perfect little points that give us whole numbers. And that should make sense as well. That's to the left a tiny bit, down -4, blah, blah, blah. Right about there. Good on the POIs? Yes. Last bit, intervals where we're concave up and concave down. So just like the intervals where we increase and decrease change at turning points, the intervals where concave up and concave down change is POIs. And now we have all those numbers, so it's just about naming them. For concavity, we always use parentheses. These are things we have to just kind of memorize, okay? When you can use this, when you can use that. So concave up would be here, right? -infinity up to what x value? What would that x value be right there? All right, keep moving it, -3. So we have an interval that goes from -infinity to -3, right? And we have another one. Where does it start? Start, you guys. Nicole, yes. Keep going, Nicole. Where does it go to? Yep, that's right. Positive infinity. If you didn't say anything because you didn't understand, please ask a question. Do we understand where I'm getting these numbers? Please talk to me. Anybody have a question? Great, do you have a question? No? Anybody? Okay. So, concave down, it's going to be between two POIs. So when you're naming concavity, you're using the x values of your points of inflection. Think about that, okay? So, concave down is from here to here. So it's the x values from this one to this one. So that would be from -3 to -0.55. Okay? So this is the kind of question your FRQ is going to be. Where you're given a graph and you have to pull a bunch of things off, just like this. Okay? No surprises. And there's one of these in your homework too. So there's lots of opportunities here for you guys to practice and get ready. All right? Good? Okay. So let me tell you your homework. I'm drowning in paper up here. Okay. So that says 13. My 13s look like a B. So find your 1.4 practice set 2. very, very short. There's plenty of more problems on here if you want to practice some, but that's up to you. I don't think we need to do a whole lot of these. Ooh, I just got a summer job reading for the AP pre-calc exams. I'm going to be one of the graders. I'm going to be grading students' tests. It's 8 hours a day for 7 days straight. You just sit and grade FRQs. But I'll become a better teacher from it and get paid $2,000. Yeah. Yeah, I know. It also looks like a B. Well, we had 12 yesterday, y'all. I usually go in order. Try to. Better. Okay, so we have this written down, 20, 22, 26, 31. Go ahead and circle them, because there was people that did a whole lot more than they needed to last period. Okay. So there's just this problem, just doing another POI problem, and then pulling information off of a graph. And I got rid of the same ones we got for the other one. Okay. So I'm going to put this up, let you guys work on it. Then I'll flip it in a minute because you guys won't take long to do this one. And I'll tell you what I'm checking. So remember the way we do it. I'm only checking one, so you just need one Post-it note. I'm going to tell you what I'm checking, find it, post it, and then go back to your homework and just wait for me. Okay? Don't just sit there. Do homework. Okay, this is what I am checking. So just take a second, find it. If you need a new Post-it note, they're over there on the cart, so help yourself. They're there for you. And I'll be around in a moment. Oh, right. Yeah, that's a tricky graph. You're right. So there's like the two that are really obvious, right? Going up right 1, 2. Then there's that 1 between POI2 and POI3. And then there must be one after POI3 that's hard to kind of see. Yeah. Oh. Yeah, so that interval of increasing, guys, that's interesting. So I just want to make sure you guys understand. The interval of increasing there, that's 2.5 to infinity, it's even though there's a little hitch in its step, a little curvy, it's still going up the whole way. So from here to infinity, it's all going up, okay? You could put a positive line through it. All of these points are increasing, okay? So it's okay that there's a little hitch in the step there, a little curvy, little side trip there. Maybe that side.